In this next problem, it says the temperature of a sample of iron with a mass of 10.0 grams changed from 50.4 degrees Celsius to 25 degrees Celsius with the release of 114 joules. What is the specific heat of iron? So first of all, when it says release of heat, we use a negative sign to indicate the release of heat energy. So this number of joules is of course our value of Q, and that Q is going to equal negative 114 joules because the heat is being released. And so that's the first thing to note here, is that our Q is going to be a negative value when we substitute into our equation. We still are going to use the same equation, Q equals M times C times delta T. Okay, and delta T is still going to be our T final minus our T initial. Okay, let's read the problem again and pick out some of these variables. The temperature of a sample of iron with a mass of 10 grams, so of course that's our M, our value of M, changed from 50.4, so that's our initial, to 25, so that's our final temperature. And we might notice here that the final temperature is lower than our initial temperature, meaning that our temperature change, our delta T value, is going to be a negative value. So our final temperature is 25 degrees Celsius minus an initial temperature of 50.4 degrees Celsius. Okay, so that would be our delta T. Now I'm going to use a calculator here because when we get into these negative numbers, it does get a little bit confusing to try and do your head sometimes. 25 minus 50.4 gives us a temperature change of negative 25.4, meaning that our temperature is dropping by 25.4 degrees. Okay. So we have our M, we have our delta T, we have our value of Q, and it says what is the specific heat, so we are looking for C. So we're trying to find our value of C in this equation. Alright, so let's substitute in some values here. So our Q, negative 114 joules equals M, so 10 grams, times C, which we don't have, so I'm going to leave C, times delta T, which is negative 25.4 degrees Celsius. Okay, so we have to do a little bit of algebra here. And the first thing that I want to note is we want to be careful not to confuse our units with our variable. So to make that a little easier for us, I'm going to go ahead and put our variable in a different color. So I'm going to make our C red, so we know that that's our variable that we're looking for. And then the other things are units, so we do need to keep our units with our values. So to isolate our variable and get C by itself, we need to move the 10 grams and the negative 25.4 degrees Celsius to the other side. So I'm going to divide by both of those, 10 grams, and divide by negative 25.4 degrees Celsius, so we can move these to the other side of our equation, because whatever we do to one side in algebra, we have to do to the other side. So we're also going to divide by 10 grams times negative 25.4 degrees Celsius. So 10 grams, and that cancels on one side, and I'm going to flip this equation around and put C, our variable, equals negative 114 joules divided by 10 grams times negative 25.4 degrees Celsius. Okay, and of course I always like to look at my units before I actually do the math of our problem. And so I notice that I have joules divided by grams and degrees Celsius. So none of my units cancel out. So my units are going to remain in my final answer. I'm going to have joules per gram degrees Celsius, which of course are the units of specific heat capacity. So this does make sense that none of my units cancel out. Joules per gram degrees Celsius will be my final unit on my answer. So last but not least, I just need to substitute this into my calculator. I'm going to do the bottom part first, the 10 times negative 25.4. When you're using your calculator, make sure you are using the negative sign and not the minus button, because they will do two different things in your calculator. Enter. So I got negative 254 on the bottom. So these things combined are negative 254. 114 divided by negative 254. Negative 114 divided by negative 254 gives me 0.4488. It gives me some more decimal places as well, but if I look back up at my problem, I have 3 significant figures, then 3 significant figures, 3 significant figures, and 3 significant figures. So my answer should be rounded to 3 significant figures. So I'm going to put approximately, keep that 1, 2, 3, and then this 8 is going to cause my 8 to round up to a 9. So my final answer is 0.449 joules per gram degrees Celsius.